Hello, in this video I'm going to introduce the concept of an acid and a base. So most people have heard of acids from mad scientists on TV that use to melt people's faces off, but fewer people have heard of a base. And it's going to be easier if you just think of a base as an anti-acid. It's like the opposite of an acid. I'll explain more later though. So I got to teach you about some background knowledge first, and that's two chemicals named hydronium and hydroxide. Let's talk about hydronium first. So this isn't hydronium, this is water. This is a water molecule. Now if I take a water and I add an extra hydrogen, we can't call it water anymore. It has a different chemical formula. So we call it something else. We call it hydronium. H3O instead of H2O is called hydronium. And sometimes you write it with a little plus because it's positively charged, but that's not necessary. It's water with an extra hydrogen attached to it. Sometimes we also represent it as just this extra hydrogen, so we write it with just H+. So if you see H3O, or you see H+, like a hydrogen, but it's positive and it's in water, it's hydronium. So the complement to that is hydroxide. This is a water molecule again, and if I don't add a hydrogen, but instead I take one away, it's a different chemical. It's not water anymore, and it's not hydronium either. This gets its own name, and it's called hydroxide. So OH is hydroxide, and it's negatively charged, so we can write it with a negative in that corner if we want to. It's water, but with one hydrogen removed instead of added. So H3O is hydronium, HO is hydroxide. You get them both by slightly modifying water. You either add or subtract a hydrogen. Now, all liquid water has a little bit of both of these molecules inside of it. And this is because the water molecules interact with other water molecules, bumping and switching the hydrogens. Like this. So normally the amounts that you have are equal because you have two water molecules, and maybe this one loses the hydrogen, and this one gains the hydrogen. So you have one hydroxide and one hydronium. But they don't always totally balance out. Normally they balance out. But if they don't, then the relative amounts of H3O versus OH will determine if a solution is acidic or basic. So basically, if you have too many of these, you're an acid, and if you have too many of these, you're a base. Acidic solutions have more hydronium, basic solutions have more hydroxide, and neutral solutions will have the same amount of both. So now you know what a basic and an acidic solution of water will look like. But how can you tell if a particular molecule is going to be an acid or a base? Like if you take this molecule and you eat it, is it going to be an acid in your stomach? Or is it going to neutralize the acid in your stomach? And the Arrhenius model is one model that we use. There's a couple, but it's the most common. The Arrhenius model states that an acid is something that forms hydronium when you put it in water, and that normally means that it has a hydrogen that it gives away. And it says that a base is a chemical that forms hydroxide in water. And this normally means that it has a hydroxide attached to it that kind of splits off. This is the most important slide of this PowerPoint. A good rule to identify if a chemical is an acid or a base. If a chemical starts with H, then it's usually an acid. And if the formula ends with an OH, it's usually a base. I'll show you what I mean with a couple examples. HCl, hydrogen chloride. Is it an acid, a base, or neither? Well, this is the chemical formula, and it's HCl, so it starts with an H. This indicates that it has a hydrogen that it'll probably give away. So it's an Arrhenius acid, because if you put it in water, like you have a water molecule and then a hydrogen chloride molecule, the hydrogen is going to leave the chlorine, attach to the oxygen, and form hydronium. So it's an acid, because it starts with an H. Example number 2. CaOH2, calcium hydroxide. Is it an acid, a base, or neither? Well, this is the chemical formula. It starts with calcium, and it ends with OH, hydroxide. So if OH is on the end of the chemical, probably what's going to happen is it's going to... I'll do it like this. So it's a base because it ends with an OH. What happens is you have the calcium hydroxide, the calcium with two hydroxides, and both of these will sort of fall off the calcium and sort of become free-floating hydroxides when they go into the water. So because I form hydroxide, I'm a base, not an acid. Final example set. I have a lot of these, and I want you to identify if they're an acid or a base. Now, acids start with H, and bases end with OH. So I'll go through one at a time. KOH. That ends in OH, so it's a base. HBr. Well, that starts with an H, so it's an acid. H2SO4. It actually starts with 2 hydrogens, but that's fine. As long as there are any of them at the very beginning of the chemical, it's probably going to be an acid. HF. Well, that starts with an H, so it's an acid. NaOH. Now that ends with OH. So if it ends with oxygen and hydrogen stuck together, it's going to be a base. LiOH, lithium hydroxide. It ends with that OH combination, and so it's going to be a base. Finally, HC2H3O2. This is kind of tricky. It looks really long. And I have an H here, and I have an H here. So what happens? And the answer is basically, as long as I have that one H at the beginning, no matter what else follows it, that hydrogen is going to fall off, get stuck to a water, and form the acid chemical hydronium. Finally, I'll tell you a little bit about what they're like. Acids are normally sour. They normally react with metals to make hydrogen gas. That's why if you pour acid on a metal, it'll bubble and sort of eat away at it. They will react with a base to produce just water. So if you have an acid and a base and you mix them together, they neutralize. They're not dangerous anymore. You'll just get water and a salt. They will conduct electricity when they're really strong, and they're dangerous when they're too strong. So you can drink lemonade, even though lemon is an acid. You can drink vinegar, even though vinegar is an acid. But you can't drink battery acid, because that'll burn through your stomach, because it's too strong. So these are 3 examples of acids. Some properties of bases. Bases are not sour. They're bitter. They feel slippery when you hold them in your hand, like kind of gooey. They can neutralize acids, turn it into water. When they're strong, they can also conduct electricity, and they're dangerous when they're too strong. So a lot of cleaning supplies are bases. For example, soap is a base. That's why soap is so slippery. And Clorox is a base. Soap is weak. You could eat soap if you wanted to. You probably shouldn't. But you shouldn't eat bleach, because that'll kill you because it's too strong. So that was it. I hope that was helpful.